Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ont. In this tutorial video, we'll go through these 14 to 16 years old combined science chemistry curriculum. This is part of the 3 sciences combined into one subject. This is organic chemistry, the very last topic in the chemistry part of the curriculum. In this first question, we have these particular processes of fractional distillation and also cracking. So fractional distillation works by separating out the different fractions of crude oil mixture based on their different boiling points. These are part of year 9 separation techniques. Cracking is part of year 11 organic chemistry, and this cracking basically is long chain hydrocarbon into short chain hydrocarbons. Because the short chain hydrocarbons are more valuable, they can make more profit for the oil and gas companies, therefore they are more in demand. You do need high temperature, which is around 500 degrees Celsius. You do need a catalyst, both of which are required in order to do this cracking. Okay, so this is an apparatus setup for fractional distillation, and cracking is somewhere there. This is pretty similar to work 1 actually. So fraction O is further down at the bottom, whereas fraction L is at the top of the fractionating column. So these tall towers there is called the fractionating column or just the distillation column. The higher up you go, there will be the lighter fraction. The lighter fraction means you have lower density, and you will be the one that boil first. So you will have lower boiling point the higher up you go. So because you boil first and you are the lightest, you get collected at the very top there. You will have the weakest intermolecular forces. These are force of attraction between the molecule based on the English words, as well as from year 9 chemical structure and also bonding. Okay, what else can I tell you? Perhaps that's enough for now. So state 2 ways in which the bottom fraction differs. Well, we know that fraction O at the bottom will be a heavier fraction. It's a heavier fraction containing bigger molecules and also longer chains, containing longer carbon chains. So there are more carbon in the molecule, and therefore a bigger molecule, and therefore it's much heavier fraction compared to the one which is further up than fraction L, which is further on top. Well, our second feature, we can talk about the difference in boiling point. As you go further down, you're going to collect fraction like bitumen, which will solidify, will form a solid, whereas the fraction at the very top will be natural gas. Going from gas to solid, your boiling point would increase. So fraction O at the bottom would have a higher boiling point, higher melting point than the fraction on top, which is fraction L. They haven't asked for the reasons, but because that is mainly due to the weaker intermolecular forces. As you go higher up, there is a weaker intermolecular forces. Doesn't require a lot of energy to break lower boiling point. Your molecule get bigger, your size get bigger, therefore stronger intermolecular force between the molecule. It would solidify at a lower temperature. That means you have a higher boiling point, more difficult to boil. We talk about cracking next. They just want one condition. So one thing that is very clear, as I mentioned earlier, you do need very high temperature. This is around 500 degrees Celsius, so heat at very high temperature. But then you should also know that we do need a catalyst for that reaction to occur. But they just need one, so any one will do. Sometimes they do ask for 2, so make sure you know 2 of them as well. Cracking involve break down long chain hydrocarbon. You could see 18 carbon there. This is CnH2n plus 2. because 18 times 2 give me 36. 36 plus 2 give me 38 there. So this one is plus, whereas previously it was multiply. This is CnH2n plus 2. This is the general formula for the alkanes family. Now, what is the value of x and y? This is part of balancing equation, counting the atoms. These are part of year 9 chemical formula and also equation. So those are all year 9 topics. Whatever that you had learned from year 9, everything comes together now. So we have got 18 carbon on the left, 18 equal to 9 plus, there are 3 molecules of C2H4. What does it mean? It means that you have C2H4, C2H4, C2H4. So it means you have 6 carbon altogether, 2, 4, 6. And we have x times 1, so that is x. So what is x then? X is 18 minus 9 minus 6. Press your calculator, you get x equal to 3 there. Could do the same exercise for y. Y is going to be 38 equal to 20 plus, well, I got 4, 4, and 4. So 4 times 3, which is 12, by the way. And I've got 1 times y. And what does this give me? 38 minus 20 minus 12 equal to y. So what is y equal to? Press that into your calculator and you get y equal to 6. And you could see that there is C3H6, CnH2n, alkene there. Part C, we have ethene. Ethene is an alkene. Alkene has carbon-carbon double bond. They want dot and cross. But then from year 9, covalent bonding. In the topic of covalent bonding in year 9, that was about 2 years ago, we talk about this carbon-carbon double bond. Then we have hydrogen forming a single covalent bond because you just have 1 electron in the outer shell. So you just want to share 1 electrons to complete your first shell. But carbon with 4 electrons in the outer shell, you want to share 4 electrons to complete your outer shell. So carbon form 1, 2, 3, and 4. And this carbon form 1, 2, 3, and 4. So this diagram is correct, but this is not dot and cross. Dot and cross was what year 9 had taught you, and we're just going back to the dot and cross now. Single covalent bond is just 1 electron from each atom. So that is what I have done there. That is a CH single covalent bond. This is a CH single covalent bond. Another CH, another CH. And now we've got a double covalent bond. Double covalent bond means this carbon share 2 electrons, this carbon share 2 electrons. I am going to have to move them closer together to represent that they are sharing electrons. 2 covalent bond. Each covalent bond is 2 electrons that are being shared. 2 covalent bond means 4 electrons that are being shared. We just want to show the outer shell electrons because the inner shell electrons are not bonding. They just want bonding electrons. Only the outer shell is used for bonding because the inner shell is already full there. Part D, we have an alkane as mentioned, CnH2n plus 2, general formula of an alkane. So they are homologous series. What is meant by homologous series? So they have the same. So compounds in the same homologous series. Compounds in the same homologous series have the same chemical properties. Just like alkanes undergo combustion reaction. So I have the same chemical property and have a general formula. And have a similar general formula and have the same general formula, i.e. for alkane, CnH2n plus 2, when n equal to 18, then 18 multiplied by 2 plus 2, this gives me 38, so therefore C18 H38. So basically, the other way of asking this question, what are the features? What are the characteristics? How do you tell if something is a homologous series or not? Well, there are other things to talk about as well. We can say that they have a trend in the physical properties as the number of carbon chain increases. Now put a tick, that is what they want, put a tick. Which statement describe each compound correctly? So you may tick more than one box in each row. You may, does not mean you will, okay? It has molecules. Molecules contain, all these particular compounds that have covalent bonds. 23 atoms. Well, 7 plus 16 give me 23. 2 plus 4 give me 6. 5 plus 12 give me 17. These are the number of atoms. So which one have 23 atoms? Only C7H16. Unsaturated. Unsaturated mean carbon-carbon double bond. Saturated mean is full. When all you have is carbon-carbon single. Unsaturated mean carbon-carbon double. So we are looking for alkene. We are looking for CnH2n. Alkene. This is 7 times 2 is 14. So it's not this thing, because this thing is going to be alkane. CnH2n plus 2. So you can see 7 times 2 is 14. This is not 14. C2H4, this is definitely alkenes. So CnH2n there. So this is what we're looking for, because C5H12 is again another alkane, where you have 5 times 2 is 10 plus 2 is 12. So we're looking for alkane in the next one. Alkane is what you call saturated hydrocarbons. Saturated means only contain carbon-carbon single bond. Hydrocarbon means only contain carbon and hydrogen. So it is an alkane. So not only C7H16, but C5H12 as well. You may tick more than one box. Alkane, alkane, CnH2n plus 2. Produces carbon dioxide and water when it burns. Yes, when you have complete combustion of these hydrocarbons, you can get carbon dioxide and water. This is true for all the hydrocarbons there. In the next question, so we have the cracking of larger hydrocarbons, and this takes place at high temperature of around 500 degrees Celsius, as well as a catalyst. But this question is not asking you on the conditions for cracking. They want the definition of hydrocarbons as stated in the syllabus. They are compounds or they are molecules. You can say compounds or you can say molecules containing only hydrogen. Only hydrogen and carbon atoms only. So there are no any other elements. There are no any other atoms except for hydrogen and carbon. We have this thing called ethene. Ethene from the year 9, dot and cross, together with the vocabulary in year 9 under the dot and cross covalent bond topic. That was about 2 years ago. We can go back 2 years ago and revisit what you have learned. Hydrogen with 1 electron in the outer shell always form a single covalent bond because it just needs to share 1 electron to complete the first outer shell, which is 2 electrons maximum. Carbon with 2-4 electronic configurations. The bonding only involve the outer shell. Only the outer shell electrons get involved with bonding. So we don't talk about the inner shell. We don't draw the inner shell. So it will share 4 electrons to complete the outer shell. Why does it share 4 electrons? Because it wants to complete the outer shell, which is the second shell, and maximum is 8 electrons there. 1, 2, 3, 4, each covalent bond containing 2 electrons there. So dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, dot cross hydrogen for each of the single covalent bond there. This is a double covalent bond. So cross cross there, cross cross, because 2 electrons from this carbon, another 2 electrons from that carbon there. So this carbon originally 1, 2, 3, 4 cross, share 1, 2, 3, 4 other electrons. Same for that carbon, completing your outer shell there. Describe a test to distinguish Distinguish means tell apart the difference between ethane, which is an alkane from the A and E part of the name, and then you have alkene, carbon-carbon double bond and carbon-carbon single bond. You can add aqueous bromine. You add bromine water. So you can say add aqueous bromine, or you can add bromine water. So carbon-carbon double bond is unsaturated. Unsaturated means you can add onto the double bond. So aqueous bromine get decolorized. So we can say bromine water get decolorizes, or it turns into colorless. So it has undergone addition reactions. So no observable change. So no change in color at all. It's not colorless. So it remains kind of orange yellow because it only contains carbon-carbon single bond, and that means it is saturated. Saturated hydrocarbon cannot add BR across your single bond there. Part B, we have the proportion of carbon dioxide that is increasing, and that is due to the complete combustion of hydrocarbons that produce carbon dioxide and also water. The danger with carbon dioxide, why is it dangerous? What is the harmful effect? Carbon dioxide is a greenhouse gas. So what does it do? As a greenhouse gas is that it can cause global warming. It can cause the whole world to get hotter. And when the whole world gets hotter, we get flooding in some parts of the world, and then we get crops that can die as a result of very high temperature. Now, combustion of hydrocarbon is an exothermic process. What is meant by exothermic? Number one, in terms of energy transformation, this is straight from year 10. Year 10, chemical energy changes, or that topic called chemical energetics. These are to do with heat energy changes. So we know that exothermic reactions give out heat energy. So what is meant by that? It gives out heat energy, it release or it gives out heat energy to the surroundings. And you will see the definition is worth 2 marks because as stated in the combined science energy changes topic, what happens when you give out heat energy to the surroundings? So therefore, it causes the temperature of the surroundings to get hotter because the surroundings receive the heat energy. So the temperature of the surroundings would increase, it will get hotter. It increases, it will increase. Therefore, get hotter. It's the opposite for endothermic reaction. Question 3. Petroleum is a fossil fuel. Name 2 other fossil fuels as stated in the syllabus. These are the possible sources of fuels. One is petroleum, and one you get is natural gas, of which methane is the biggest component of natural gas we have. And the other one that we have would be coal. So many parts of the country in the world are still using coal as a power source for their power stations. So what is this process? Name it. To separate the substances in petroleum, which is a mixture. So what we are doing is we separate them in the fractional distillation column. So this technique is called fractional distillation. Year 9 separation techniques, also part of lower secondary science. Distillation involves boiling the petroleum mixture based on their different boiling points. They will condense. They will go from gas to liquid condensation into different fractions at different positions of the tower from the top to the bottom based on their different boiling point there. Now we have structures of 2 hydrocarbon molecules. We could see that is C3H8, 3 carbons, 8 hydrogen, 1, 2, 3, 4, 5, 6. This is 6 carbons and 14 hydrogen there. Construct the balanced chemical equation, complete combustion, hydrocarbon A. So complete combustion will give you carbon dioxide and also water. Part of environmental chemistry, part of year 10 there. Part of year 9 is to know the vocabulary, that the chemical formula for carbon dioxide is CO2, formula for water is H2O, should be able to convert the CO2 and the H2O into the dot and cross diagram correctly based on year 9. Year 9 already taught you how to draw dot and cross for covalent compound CO2 and also H2O, both of them included there. So compound A, C3H8, reacts with oxygen, burns in oxygen, carbon dioxide and water. Year 9 balance equation taught you everything on the left must balance everything on the right. 3 carbons, cannot change the formula there. So what I do is I put a 3 in front, that means 3 times 1, 3 carbon. Next I got 8 hydrogen, cannot change the formula there, I already got 2. Something multiplied by 2 will give me 8 hydrogen, that is 4 times 2 give me 8 hydrogen. Next up I got 3 times 2, which is 6 oxygen. Atoms, molecules and compounds is part of year 9 atomic structure. I'm talking about the atoms. They have 1 atom in 1 H2O. They have 4 molecules. 1 times 4 is 4. Altogether 6 plus 4 give me 10 oxygen atoms. So we need 10 oxygen atoms. But oxygen exists as a molecule. Year 9 chemical formula, structure and bonding, dot and cross. You want to complete your outer shell. Therefore, you just need to share 2 electrons, 1, 2. This oxygen also 1, 2. You form a double covalent bond. Diatomic molecule. 2 atoms bonded together by covalent bond. It's an element. Element contain only the same type of atom, therefore only 1 type of atoms. Something multiplied by 2 give me 10, that is 5 there. That is the balance equation. Complete combustion of this hydrocarbon A, counting the actual number of atoms in one single molecule there, molecular formula. That's it really for this work 2 tutorial for the combined science 14 to 16 years old organic chemistry curriculum. Don't forget, click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry, that's at ptet.chemistry on Instagram, Facebook, Twitter and Telegram to get connected.